Okay, so this is going to take us back to the first time we ever talked about a table of values. So a table of values, what you sometimes forget being in advanced algebra like this, is that when you go to graph lines on a graph, you can probably just look at the equation and graph it. But what you forget is that it all originates from a table of values. So let's kind of go back to this. And if I were to say to you, here's the equation, y equals, we'll keep it easy, 3x plus 2. And if I were to say to you, I want your domain or your x values to be -1, 0, +1, okay? And then just ask you to graph that. You're kind of looking at me thinking, what do you mean? How do I graph it? Well, if you have your domain, these are your x's. And do you remember we talked about the little machine where you put your input machine and it outputs another number? That's all you do. So these are your inputs. You're going to input this here. So back in maybe 5th or 6th grade, I made you show, or your teacher made you show your work. You had to put a -1 there, and then they made you show that 3 times -1 is -3, and 3 plus +2 resulted in a -1, right? So when I made x -1, y also happened to become -1, okay? Then you had to do the same thing for 0. When x was 0, you had y equal to 0 plus 2, and y equals 2, okay? Now, are we at the stage where you can kind of just look at that stuff and do those calculations in your head? Yeah, you should be. So you don't have to show any of this. I'm just kind of showing you where I got these answers. So as the students that you are now, you're just going to look at that and say 1. 1 times 3 is 3. 3 plus 2. So you're going to be able to create these table of values in your head without showing that work. Okay, so understand that. Okay? Now, once you have a table of values, these table of values become ordered pairs, right? And then those ordered pairs become points on a graph, right? So if this was not a function, we're not talking about a specific domain, we're just talking about graph that line, then you would just take this and you have point -1, -1, 0, 2, 1, 5, and then you would put those points on a graph like this. So you would say -1, -1, 0, 2, and 1, 5. Okay, so I mean, you could just sketch it on your sketch. Just means, it means there's no lines. Just sketch it. So a rough sketch would be -1, -1, 0, 2, and 1, 5, and there's your line, right? Okay, that's what you did in maybe 6th grade or 7th grade algebra or pre-algebra, right? So we're going to take the same concept, and I like to throw this out there too, that I could then right now, technically, give you any equation. I could give you x squared minus 2x plus 7 and ask you to graph it. And you probably look at me like, I don't know how to graph that. You haven't taught us how to graph it yet. But I kind of have, right? You just don't know it. Can't you just pick some x values, create a table of values, and find the y values and plot those points? So if you wanted to, you could say 1, 2, 3. I'm going to make x1, see what the y is. I'm going to make x2, see what the y is. And then graph it. That's not what we're doing today, but just so you know, I can give you any y equals x to the 4th minus 7. You may not have any clue what that looks like as a shape on the graph, but you don't need to, because you can pick your x values, plot them, and create the graph of that function, or that line. Okay, so here's what the deal is for today. How does this relate to what we're doing today? What we're doing today is I'm giving you a function, like, for example, -2x plus 1. And I'm giving you a domain. So I'm going to say the domain is -2, -1, 0, 1, and 2. And that's your domain. And you need to graph it. So let's go back to the last check for understanding we took, not yesterday, but the first one. This is it flipped around. Didn't I give you the graph and you had to tell me the domain? Right? So I gave you some crazy looking graphs and you had to tell me what the domain and the range was. Backwards. Today I'm giving you the domain. You need to find the range that corresponds with those domains and then graph it. So it's kind of reverse. That's all. So if you look at it like that, you'll be fine. So I need 2 things from you today. I need to see your table of values, And then I need to see your graph. Those are the two things that are going to be worth points. So I'm going to fill in my domain, which is given. This is going to require a little bit of thought too, so let's kind of stay on top of this. So negative 2 times negative 2 is positive 4, plus 1 is 5. Negative 2 times negative 1 is 2, plus 1 is 3. 0 plus 1 is 1. Now, technically, I could stop right here because, does anybody notice that I don't have to keep doing these substitutions? As long as these are going up at their constant rate, like these are going up 1. For every 1, these goes up, this goes up, or actually down, 2. 2. So what technically would be next without me even having to do the substitutions? Negative 1, and then negative 3, right? Okay, so I shouldn't have to do that. And now my next thing, just a side note, is it any coincidence that this is going by negative 2 and the number in front of x is negative 2? It's not a coincidence at all. It's the reason that's going down by 2 is because that's the rate of change, right? Isn't this your rate of change? Isn't your rate of change your slope? Isn't your slope in front of x? So that's coming off second try. Okay, so now that I have this, I want you to stop for a minute, and this is where some thinking comes in, because that was kind of easy. So I'm going to put a point at negative 2, positive 5. I'm going to put a point at negative 1, positive 3, at 0, 1, at 1, negative 1, and then at 2, negative 3. And then at this point, your first instinct is probably to take a ruler, and I'm going to get a pencil for this one. Up until this point, before we talked about functions, you probably went, there you go, right? Well, this is a function, and the function, the domain for this function can only be those numbers. If I didn't show you any of this and I just gave you this graph, what would you tell me the domain was? All numbers. Wouldn't you say, hey, I don't know, but the line that you just plotted, the domain for that's all numbers. Does this say all numbers? No. So what can I do? I'm going to use an eraser. What can I do with this eraser to make this graph match that domain? I can erase. Somebody said erase the lines or the arrows. So I erase the arrows and it still doesn't match. So now it just stops at 5 and negative 5. I'll have to erase more, Sam. Yeah, we'll stop at, not at 5 and negative 3. My domain, guys, remember what we did when we did this? My domain can only go as far to the left as negative 2 and as far to the right as positive 2. These are the only numbers that my domain can be. So is this part covered? So this has to get erased, right? So does that match your domain now? So the only numbers that your x values can be are negative 2, negative 1, 0, 1, and 2. Right? So don't just assume you're going to go nuts and start drawing lines with arrows all over the place today, because you're not. Okay? So let's take a look at our second example and kind of see what this does. So let's take f of x is equal to 1/2 of x plus 4. And this one, I want your domain to be greater than or equal to 0. So, let's talk about what that domain means. Does it tell you it can only be certain, like 1, 2, 6, 7, 8, 9, 10? No. It tells you it can be whatever number you want it to be as long as it's what? Greater than or equal to 0. So for my x values, I just can't put any negatives, right? Make it easier on yourself. Just put them in order. So include 0, 1, 2. Your table of values only needs 3 points today. You don't have to go 5. So give me 3 points. 0, 1, 2. Actually, for this, what would be better values to choose because of the half? Because are you going to want to do a half plus 4? So whenever you take a half of something, it means you divide it by 2. So what kind of numbers do we really want to use? evens. So would 2 and 4 maybe be a little less of a headache? I mean, it's not horrible. You can do it, but why if you don't need to? So half of 0 is still 0, and 0 plus 4 is 4. Half of 2. I need to make sure you're understanding this. Right? Half of 2 is 1, and 1 plus 4 is, and half of 4 is 2, and 2 plus 4 is, okay. So I have my table of values. That's 1 point. And now I just need to graph this. So this is where it gets a little tricky, because it's all about, are there arrows? Does it have to stop? Where does it go? So let's do 0, 4. Let's do 2, 5, 2 comma 5, and 4 comma, wait, how's that? Oh, okay, I was going to say, that's not right. And you know what? That's actually really good that it happened. What made me stop and think something's not right? Because I knew that they weren't going to be on a straight line. And I knew that in order for it to be a function in linear, that it does. So 0, 4, did I say 0, 4 at least? I just put it on 0, okay. So 0, 4, 2, 5, 4, 6, that's more like it, right? Okay, before you pick up your ruler, let's stop and think about this. The domain has to be greater than or equal to 0. So, can it be 0? Yeah, and I guess I probably should have thought about that before I put that point and colored it in, right? Okay, I'm going to show you next what happens if that line's not there. But what do I need to do now to this? Think about when you highlight it. What was a domain greater than or 0? What did that look like to you? Doesn't it look like that? Is that okay? So do you understand this time why I extended that arrow and kept going with it? Because it doesn't stop at -2 or +2. It doesn't have to be in between. It could be any number greater than 0. Do you understand that? Awesome. Okay, so let's do another one then. This one is a little trickier. How about we do h of x is equal to -x plus 6. Okay? And this time I want the domain less than -2. So I want to kind of see because there's something here that you got to be kind of a little careful of. I want to show you two things. Actually, I don't know if I want to show you first. I want you to just do it first, because I want you to kind of see something on your own. So go ahead and try that. Your domain has to be less than -2. The only hint that I will give you is this. This also means the opposite of. So this is what I do. I purposely gave you a domain that's negatives because I want to see what you do when you put that negative into that opposite of x. So for example, if you happen to choose -8, which I wouldn't, you're putting -8 in there, and what's the opposite of -8? +8. Okay? So if I chose x at -8, then I put -8 in there. -8, the opposite of it is +8 plus 6. That would be 14, right? So just know that when that's that. But what if I chose, I can't for this particular example, what if I chose my x to be a positive number? Then it would be -7, right? It just means the opposite. So go ahead and try to figure that out. And I want you to kind of, because notice there's no line there. It's going to throw you off somehow. So go ahead and make your table how you think you should. And I'm going to see if anybody includes something that you're thinking that you shouldn't. You actually should. And we'll see why. Looks good. Okay, so when you created this table, before we did this, I want to kind of show you something here. Yeah, I like it. Looks good. Yeah, the only thing is there's a yeah, I'm recording notes right now, otherwise I'd show you. But they're going to have to put a text strip up and whatever. So when I put a 6 here, and I ask you to graph all numbers that are greater than 6, where do you start? Do you start at 7? Did you put a circle at 7? No. So didn't you start at 6, but just not what? Color it in? And then you just went this way? Because if you start at 7, you're forgetting about what? All of those rational numbers in between. So how many of you thought to actually include -2 in your ordered pairs? Okay, probably not a lot of you. Let me explain why it's actually good to. Because let's just do this. You guys probably chose -3, -4, -5, right? Then did you say the opposite of -3 is 3, and 3 plus 6 is 9? The opposite of -4 is 4. 4 plus 6 is 10. The opposite of -5 is 5. So, you got that, right? Versus -2, -3, -4. So this would be 8, then 9, then 10, right? Okay, so let's look at the difference. And this, hopefully, you will realize, because we had kids in first hour debating. Somebody said, you can't put -2 there because there's no line. And somebody said, well, just watch when I graph these. So when I go to plot this, -3, 9, -3, 9 is right here. -4, am I going up? Yeah, I guess I wish I would have chose better numbers so you to see it better. But -4, +10. And then they're telling you one more. Let's just do -5, +11. That the domain has to be less than -2. But right here, is that a domain of less than -2? That's a domain less than -3. What about, aren't these numbers less than -3 but still, I'm sorry, greater than -3 but less than -2? Okay, so watch what I'm trying to say. You do need to include this point, except just put what kind of circle there? Open. Do you see the difference in the graphs? By starting at -3, which was your first instinct here, you can use this to find that point, but just don't circle it in. Got it? Otherwise, you're forgetting about these numbers in between. So, I know what you're thinking. It can include -2, so you know what? You're just using this table to get to your points. When you so this can be in your table, because you need to know that matching value, just don't color it in, right? Okay, let's do another one. Let's do this. So, f of x is equal to 3x minus 2 with a domain greater than 4. So, create your table of values. Thinking about what I just said, you're going to want to include that 4 in your table, but just when you go to graph it, be careful. Did you choose 4, 5, 6? Okay. 4 times 3 is 12. 12 minus 2 is 15. Minus 2 is 18. Minus 2 is... Okay, and I know your graph doesn't go up that high, but I should have chose better numbers. But so now looking at this, watch what I do. I go to 4, 10, except I would what? I put an open circle, right? Because at 4, 10, 4 is not part of my domain. So I know I'm kind of running out of room here, but what if the graphs fit better on the homework assignments? So 5, 13 would be like up here. And then 6, 16 would be up here. And then what do I do? Does it have an arrow? Yes. Got it? And here's how you check it. Pretend like that was the graph that was given. If I follow this down, is this a domain that's greater than 4? Yeah. That's how you check it, just like what you did. Okay, I'm going to show you one more because you might be a little confused. You're going to see this. H of x. Okay? With a domain, let's see, our domain can only equal -3, -2, and -1. Okay. Last example. So, according to my domain, do I see that it has to be greater than or less than? Am I going to have any arrows on my? No? -3, -2, -1. So I'm going to put -3 here, subtract 1 from it, but be careful. The answer to that is not -4. It's the absolute value of -4, right? And the absolute value of -4 is +4. So a +4 goes here. Got it? So then obviously -2 minus 1 is -3, and the absolute value of -3 is +3, which means this will probably be what? 2, okay? Because as long as this is going up or down at a constant rate, you can use this difference. So now when I go to graph it, I have to be aware of what my domain can be. I can only have 3 numbers be my domain. So I'm going to plot these points. -3, +4. -2, +3. And then -1, +2. And what do I do for that? Technically, could I just leave it? Yeah. But if I do decide to connect, then it only can go there. That's it. Got it? Okay.